check, and microphone is working. Yo guys, morning to all of you, or afternoon, or wherever you are. So hopefully this is going to be the last live stream of the Sundown 6K. I have been poking around with it over the last couple of hours this morning, and I think I have a new lead to go on. So I think, fingers crossed, we will resolve the issue today in today's live stream, and it's a very, very strange one. There's still a lot of digging I need to do, but I've noticed something that is different on this when you plug the board in. So I'm just going to wait for the viewers to pick up a little bit, and then I'll explain what I have had going on. But I hope you guys are all good. We're getting towards the end of the week now. Getting towards my trip to the States, which is starting on Sunday. I leave the UK on Sunday, and I'll arrive in Chicago on the Sunday, and we're only stopping there for a couple of hours. It's just a stopover, and then we land in Dallas, and then I go off to Oklahoma with Chan and Jassa at DD. Oh crap, I just reacted to something that I didn't mean to. You know when you're scrolling on Facebook and you accidentally react to something, like a comment because you're scrolling through and your finger just like reacts to something? Hate it when that happens. Okay, so I think there's probably enough viewers now for me to start explaining what I have found on this. 28 viewers, yeah. Okay, so good afternoon, good morning, good evening to all you guys. Now, so if you haven't been following this amp repair, then where the hell have you been? And it sucks to be you, because this has been a really, really interesting, complicated amp repair that has probably been a source of good information, both for myself and for you guys. A nice learning curve for us. But if you haven't been watching this one, then the main issue is this. The amplifier works beautifully fine. Works absolutely fine. The amplifier comes in two halves. Well, I say two halves. The amplifier actually splits. So you've got the main amplifier board here. So this is the amplifier board. But then the RCA input board with all the potentiometers and everything is actually a sister board, which is attached into the edge like so. And so the amplifier works perfectly fine with just this board attached, but as soon as you slide the preamplifier board in, the amplifier still works, but when you power it up, like so, if you power the amplifier up with the board attached, soon after you've recently powered it down, then the output FETs all glitch and they suddenly go to negative rail for a split second, like a massive spike, and then it works again. But sometimes when that spike happens, the FETs blow. So it's obviously not happy about something. There's obviously some tiny issue somewhere that is causing the amplifier to spike when it's turned on, when the amplifier has only recently been shut down. Now, I could give it back to the customer and I could say, you know what, it works fine, just don't power it up again after it's recently been powered down. Just give it 5 minutes or so. But you know, there's still some underlying fault here, and I believe this fault was present from factory. I don't think that this has happened when the amplifier failed. It seems to be too much of a far-fetched, weird area to have been affected by the output section blowing. I don't think that that would be the case. Are you going to re-upload the stream later? Yeah, what I'm going to do is all the videos from this amplifier repair I'm going to activate on my channel so you can watch it later. But just be aware they are very long videos. They're like 3 hours long, 4 hours long per video because this was a big headache. If I had the spare time, I would go through and I would edit all of these video clips, and actually, sadly, if I had a powerful enough laptop, that's something I could be doing on the aeroplane on the way to the States. But sadly, my laptop is still using a Pentium 4 with 2 GB of DDR2, so there's absolutely no hope in hell that it can run Sony Vegas. But there you go. So yes. So that's the problem that this amplifier was happening, and it's not a design error. It's actually, oh, I don't think it's a design error. I think it's just some underlying fault that was present at factory that they didn't pick up on in Q&A, not Q&A, quality control. So I'm going to show you guys what I've found now recently. So just again, in case you weren't watching recently, I have disabled the MOSFETs so that the output MOSFETs are not enabled. I have lifted the gate resistors so the output MOSFETs are receiving no drive. So that means I can actually turn the amplifier on and off many times without the risk of blowing the FETs because they're not being driven, but I can still see the glitch happening on the low side drive wave. And to show you what I mean by that, let's take a look at our scope, turn my scope up to 10 volts divide and increase this considerably so that we can actually see the drive wave here up here. So let's go ahead and power the baby up. Okay. So this, my friends, is our low side drive wave. Now, if I turn the amplifier off and turn it back on again, what's going to happen is there's going to be a big bump up. So basically this is off and this is on. So this is turning the FETs off and this is turning the FETs on. Now when the amplifier powers up, it should just instantly generate this square wave and there shouldn't be any bumps or pulses before it does so. However, at the moment, when the amplifier turns on after shortly being powered down, there's a big bump to on and then it builds the square wave. Watch this. Off, buff, on. Did you see that bump? It goes bump on, like that. Do it again, bump on. So that bump there is actually what is causing the FETs to spike to negative rail and sometimes blow them. Just to confirm that, just to prove to you that that is the problem here, if I'm going to go ahead now and I'm actually going to remove the preamplifier board here from the circuit, so let's take that out. And now if I do the exact same thing, exact same test, if I probe the low side drive and turn the amplifier on again, watch what happens this time. Off, on. The wave just builds beautifully smooth and instantly. There's no bump up to the on, it just suddenly builds the square wave. So that is the problem here. Now, what I have found whilst probing around with this is actually something to do with the voltages that are supplied to the driver card. So the driver board is here right on the edge of the amplifier, and this middle set of pins is what contains the small power supply voltages this amplifier works with. So we've got plus and minus 5 volts, and plus and minus 5 volts are what the PWM generation circuit uses. So the TL072C and the LM211 uses this plus minus 5 volts. So let's take a look at the plus minus 5 volts real quick. So I'm gonna turn my scope back onto the different settings so you guys can see so far, and I need to put that down to 5 volts. I need to zero this in again. And I need to turn on probe number 2 so we can see the comparison of these two waves, of these two voltages. So let's take our first probe and let's have a look at the, I think this is going to be the negative 5 volts. There we go. So it's 4.9, it's about 5 volts. And now let's have a look at the positive 5 volts. So here we go. So this is the positive and negative 5 volt rails. You can see we've got the negative rail on number 1 on VRMS 1, and VRMS 2 is the positive rail. Okay, now if I remove the remote and power her up again, see how these voltages, see how these voltage rails build very, very evenly. So they both climb to 5 volts at the same rate, and they both reach 5 volts at the same time. See this? They're absolutely parallel perfectly. Boop, Okay, right. Now, watch what happens if I reattach the preamplifier board to the circuit, and we're going to probe those voltages again. So we attach the preamplifier board, and I've deliberately only attached, so the preamplifier board has two sets of pins, right? This side of pins has the output from the, has like the speaker output, so the sine wave signal output to the driver board, etc. and some other bits and pieces. I'm deliberately leaving that out because this side, this connector doesn't have any impact. It's only when this side is connected, well, either when both are connected or only this side. So it's these pins over here that cause this issue. So now watch what happens if I probe the same two pins. I'm going to probe negative 4 volts and positive 5 volts and turn to the scope view. Watch this. Wait. Okay, so turn the amplifier off, turn it back on. What the hell? You see that? That looks completely different to how it does with the board disattached. You can see there that the negative 5 volts is charging much before the 5 volts. There's a big delay between when the 5 volts charges. Now what that will mean is that the PWM generation circuit on the driver board, the LM211 and the 072C, that means that those chips will be receiving their negative voltage rail before their positive voltage rail, and thus it will be sending some DC spike to the PWM, which means that then gets sent to the drive ICs, which means that then gets sent to the FETs. So for some reason, it's either a design flaw in that this amplifier, because obviously the reason that this is probably happening is because this preamplifier board is using one of those voltages, the +5 or something like that, and so therefore it's demanding extra current from the +5 volt rail compared to what it is demanding from the -5 volt rail, which is probably why there's a delay on the 5 volt rail when it's plugged in. But once again, if I remove this board and we go back to the scope and we look at the rails again, now all of a sudden they're perfectly in line once more, and there's no delay on the +5 volt charging. So in order to fix this amplifier, whether I'm fixing a design flaw from factory, or whether I'm fixing some quality oversight, or whether I'm fixing some problem that happened when the amplifier blew, I need to find out where that 5 volts positive is generated from. Is it being delayed because it's weak, so for some reason it can't provide the current necessary? Is it being delayed because there is some component on the preamplifier board which is drawing too much current from the 5 volt rail, therefore delaying it? Yeah, that must be what it is. So in this video, I'm going to go ahead and we're going to trace back where the 5 volt rail is generated from, and we're going to probably change every single component along the way to try and eliminate the issue there. If we change every component along the way on the main board and it doesn't prevent the delay of the 5 volt rail coming to life, then we're probably going to have to blame something on this board. But the interesting thing is that this preamplified board doesn't use the 5 volt rail. It only uses the +15 and -15 volt rails. Now the interesting thing about that is that the 5 volt rail will be generated by the 15 volt rail. So on the amplifier, on the main board here, let's flip this over. I'm going to turn this off and I'll flip this over and explain to you how all these different voltages are created on the board. So let's turn that off, flip that over like so, okay? So you're familiar with the amplifier and the power supply section, and how the power supply turns 12 volts from the car into, in this case, a plus and minus 100 volts DC for the output FETs and the speaker audios, etc. to work on. However, because this amplifier is using some small chips like op amps in the preamp circuit and drive ICs, they won't be able to be run off of 100 volts because they'll explode. You know, their VCC rating is going to be, you know, somewhere like a 5 volts or a 12 volts or something like that. So therefore, the power supply section of the board needs to not only generate the rail voltage, but it also needs to generate some smaller voltages that the amplifier's drive circuit can use. Now some amplifiers, the power supply circuit doesn't generate these specific voltages. What it does is it just generates the rail voltage, and then somewhere in the output section there'll be some voltage regulation circuit using a rectifier diode or some kind of step down sort of system that generates the lower voltages from the rails. However, the problem with generating these 5 volt, minus 5 volt, 12 volt, 15 volt, etc. voltages from the main rails is that when the input voltage to the amplifier, 12 volts and 14 volts, fluctuates, so does the rail voltage, which is why you get more power from the amplifier when you apply 14 volts versus 12 volts. So if the plus minus 5 volts and 12 volts and 15 volts is being referenced to rail voltage, when the rail voltage goes up and down due to amplifier voltage drop or due to different input voltages, then those 12 volt and 5 volt rails are also going to move. They're going to fluctuate around. So you need to have a supply of low voltages that the drive ICs can use that isn't affected by changes in input voltage on the power supply and changes in rail voltage due to voltage drop or amplifier operation. So the way that this is achieved is on the power supply section, there will be some additional smaller winds on the output of the transformers. So this is the power supply transformers, which change the 12 volt switched signal from the FET into the plus and minus rails that the rectifiers then turn into DC. But on the outputs of the transformers, not only do you have the winds for the rail voltages, you also have some really smaller, much shorter winds on the outputs of these transformers. And what these will do is these will, rather than take 12 volts and turn it into 100 volts, they'll plus minus, they will turn 12 volts into plus minus 20 volts. Okay. And obviously that plus minus 20 volts will fluctuate with the amplifier's input voltage. However, this plus minus 20 volts is then rectified by these small rectifier diodes, which you see here, and then smoothed by capacitors. That then goes all the way from the power supply section of the board all the way over here to a voltage regulation circuit. Now these are voltage regulator ICs. They look like MOSFETs possibly, they possibly look like they're TO220 parts, but they are actually voltage regulators. The model numbers of these are KIA 7915 and 7815. So 7915 will generate the negative 15 volts and 7815 will generate the positive 15 volts. Now because these are voltage regulators, what they are trying to do is they're going to take any voltage you give to them on the input and they're going to make it 15 volts. The higher the input voltage that you give these, the hotter they will run in order to generate 15 volts, because there's more of a potential difference between their input and their output. So obviously that's the reason why the power supply's small winding is generating 20 volts, because it's high enough to not be affected by voltage drop across the power inputs, which means that it will still be generating around 16 volts when the amplifier is at 10 volts worth of input, and then when the amplifier is at 15 or 16 volts worth of input, which is its limit, it might be generating 25 volts, which is obviously going to make these work a little bit harder, but it's still very low voltage. It's still very small amounts of difference between 25-30 volts and its regulated 15 volts. So this is the way that the amplifier generates a constant supply of 15 volts plus minus for the driver circuits. Now because 15 volts is nice and low, and we don't only need 15 volts, we also need 12 volts, and we also need plus and minus 5 volts. The plus and minus 5 volts is actually generated from the plus and minus 15 volts. So what there'll be is, rather than being some amplifiers, there'll be another set of voltage regulators that will take the 15 volts down to 5 volts. But in this amplifier, I can't see any other voltage regulators. So what it's probably doing is the 5 volts is probably just being generated by a series of resistors, perhaps, that will be lowering the 15 volts down to 5 volt. And the reason that the 5 volts is taking a little while to turn on could be because a resistor is bad on the path for the 5 volt generation to the plus and minus 15 volts regulators over here. That's a lot of talking, my mouth has gone dry now. So hopefully that is a little insight as to how the amplifier is generating these smaller voltages for the drive circuit to operate. What we need to do now is we need to trace back the 5 volt positive rail and find out how that exactly is generated from the 15 volt regulators, and replace some of those parts along the way. So in order to trace that, I'm going to turn the board over just now, and we're going to start following the traces on the board for the 5 volts. So let's see, what's the best camera angle to do this with? I think it's probably going to be the head cam. Okay, so I've got to remind myself now which one is the. I think the positive 5 volts was. Damn it! I think it was pin number. The third pin along here. I'm pretty sure it was. Okay, so this pin doesn't actually have a trace on the bottom of the board, so actually I might have to go ahead. I can either turn the board over and follow the trace on the top of the board, or I can put my multimeter to continuity setting, which is this, beeps, and I can then just slide my probe over the board until I hear a beep, and that's where it's coming from. Ah, here we go. So it looks like it's coming from over here, this side of the board. Okay, so I think that was the 5 volt regulated pin. Yeah, so let's have a look then. What is that pin connected to on the board? That one is just there. So if I put my finger on it to get a reference point, flip the board over, let's have a look. Okay, so it looks like we've got a couple of very small transistors in here. These actually are voltage regulators. I apologize, I didn't spot these earlier. I thought they were just very small transistors, but these are actually voltage regulators, just in a very, very small package. Yes, so this amplifier is in fact generating what looks like the 5 volt rail from a couple of very, very small voltage regulators. Now let me wait for my camera to zoom in here. Now this is a Kia 78L. L05, here we go. Sorry, the numbers are obviously too long to fit on there. So this is, obviously the plus and minus 15 volts you've got over here. So these are Kia 7815 and 7915 on this one. So you can always tell the voltage regulator, the 7 is, I don't know what the 7 stands for, but maybe the 7 stands for regulator. And then the 8 is positive and the 9 is negative. And then the next two numbers follow is the voltage that it's regulating to. So 7 regulator, 8 positive, 15 volts. 7 regulator, 9 negative, 15 volts. So if we look at these tiny little baby ones in here, these are really cute. I've never seen a voltage regulator this small before. That's really cool. So there, when that will focus. So we've got Kia, and then we've got 7 regulator, 8 positive, L, which must maybe mean small, or like this package type, 05. So that is the 5 volt positive. So this is probably and possibly the component which is giving us the headaches here. It's this positive 5 volt regulator perhaps. But it might not be. Because remember, the issue only presents itself when we plug this board in. And this board does not use the 5 volt regulated voltage. It uses the 15 volt plus and minus. So therefore, why would plugging this board in cause excess current to be drawn on the 5 volt regulated IC? Because this one isn't powering anything on this board. Therefore, this IC, this 5 volt regulator, must be taking its input voltage, its source, from the 15 volt regulators. And so if the 15 volt regulators are powering this board here, then therefore it must be the 15 volt regulation circuit that is actually at fault here, and not necessarily the 5 volt regulation circuit. But there are some tests that we can do to confirm which is the case. And to do that, we need to power the board up once again. So I'm going to flip the board over so we can probe the pins easier on the bottom of the board, because each components are very small and I don't want to slip my probe and short something out here. So if we take a look on the board here, on the back we can see that we are looking at the same stuff as we were on the top of the board. So the 3 pins here, these are the 3 pins for the positive 5 volts, these are the 3 pins for the negative 5 volts. So positive 5 volt, negative 5 volt, and then obviously we've got the TO220 parts on here for the 15 volt regulation. So what I'm going to do now is I'm going to power the board up once again, and I'm going to first of all power the board up without the, no, I'm going to, yeah, fuck it, I'm going to plug the, I'm going to plug this board, this preamplifier board in, and I'm going to work my way backwards on the board from the driver board that we saw the lack in 5 volts. I'm going to work my way back and find out where that delay starts. Whether does it start right at the 15 volt regulators, or does it actually start at the 5 volt regulators instead? So let's take our multimeter probes and let's start having a look at this. I'm going to give you to the give you to this view. What we've got going on in the live chat. So the problem was a regulator. Possibly, we're not sure yet. You see, it could be a regulator or it could be a current limiting resistor in line with the regulated voltage. So let's just confirm that we still have our problem. Let's put our probes back on here, back on the driver board. Let's just find that same issue that we had again. Let's helps you turn the power supply on. So let's see those 2 voltages once more giving us a problem. Off, on, there we go. So there's the delay in the 5 volts. Okay, so what I'm going to do is I'm going to keep my probe on the negative one here, so we can still see the negative one build nice and clear. And I'm actually going to take my positive probe and I'm going to go ahead and put it over here on the 5 volt regulator, which was where were the pins for that? Over here. Okay, so let's see. That was obviously the ground pin I chose to probe there. Okay, so yes, this is the pin that it's delayed on. Damn, I wish I could switch between the scope view and this on my foot pedal, but I'm having to do this. So this here is obviously the output pin for the 5 volt regulator. You can, yes, the scope stays on the screen. I'm going to keep the scope there on this screen here so you can see what I'm doing. So that's the output pin of the regulator. So if I now probe the input pin, is there a delay on the input pin as well? Possibly. I need to probe the input pin of both of these regulators to see the differences here, because obviously it's a bit higher. So we've got plus 10 volts there on the input to the 5 volt regulator. So the 5 volt regulator is halving the voltage. Okay, so but in order to see whether it's an issue, I need to probe the input pin of these regulators to find out. So the input pin of the negative is going to be the center pin here. Okay, so let's go ahead and see whether these build at the same time or whether there's a delay here as well. That's difficult to tell. There's definitely a bump in the 5 volt in the positive one. Is there maybe? It's very hard to tell. I'm going to turn my scope onto a much slower setting here, and maybe we can see the bumps in a better way. So I'm going to slow my scope down a lot and see whether we can. No, that doesn't really help. That just makes it really glitchy. Okay, let's speed it up a tad to 10 milliseconds. Okay, no. Let's speed it up again to 5 milliseconds. No, they seem to build equally, don't they? They seem to build really equally there. Boom. Boom. I'm going to give you the scope view again. Yeah, this is my insulation from the 100 volt rail. I did get a nasty shock earlier this morning when I was working on the amp. I got 100 volts DC. No, what was it? Shit, I think I got 200 volts DC potential to my fingers. It was not nice. It felt weird. Okay. They look pretty even to me. What do you guys think? Yeah, that looks pretty smooth and even to me. Compared to the output of this, so if I now go to the output, see, the output looks a lot different. There's a massive delay on the positive. You see the delay on the positive there, and that's not present on the inputs. So I would say that perhaps at the moment we are looking at blaming the 5-volt regulator. Okay, and there's nothing in between the 5-volt regulator and the driver card. There's no like current limiting resistor or anything like that. So we've not got anything else there to blame. But what I am going to do is, you see the inputs to the 5-volt regulators. This one, which seems to be smooth. So this is with the preamplifier board attached. So I'm just going to kind of keep doing this just to get in my head exactly the characteristics of how that builds. It's pretty nice and smooth. And then now I'm going to remove the preamp board, and I'm going to see, does that look the same? I think it looks pretty much the same. I'm going to do something slightly different here with my scope, right? So I'm going to leave the amplifier turned on. I'm going to try and hold the 2 probes with my hand. I'm going to just shift the voltage is down here, so that at the top of their regulated voltage, they both reach 0. So that will show me when they are both reaching the 0 mark. So you see that? So now when they're both doing the positive and negative 15, they both reach 0. So if I turn them off, they'll jump up to where they were before. Okay, so that's now off. Okay, so if I go on, you can see them now both reach the positive together. So I've kind of inverted the phase on, as far as my scope is concerned, of these pins, right? So now I'm going to plug this board, the preamp board, back in. And I'm going to compare that, and because that should make it easier to see on my scope what's actually going on here. So let's probe those 2 pins again, the same. That was this one and this one. Okay, now obviously the voltage is less because we've got some current being drawn from the preamp board, which is lowering the voltage. So let me just tweak that again, calibrate that to 0. Okay, off, on. Yeah, that builds pretty much bang on. Okay, so I would say that we're blaming the 5-volt regulator. I'd say that we're blaming the 5-volt regulator. There doesn't seem to be that sort of delayed issue doesn't seem to be present before the regulator, but it is present after the regulator. Okay, cool. So I've never seen those tiny SOT89 package regulators before. I don't know if I have a donor board that actually contains any of those. So either I'm going to have to order a couple of those 5-volt and negative 5-volt regulators, or I could try and install some bigger TO220 package regulators. That might increase the reliability of the amplifier as well, but I don't know how well those will fit in these locations. Actually, no, they should fit. Yeah, the pin width looks about the same width actually. So what I'm going to do is I'm actually going to go ahead and I'm going to look at my donor board pile over on the shelf, and I'm going to see whether I happen to have any 5-volt regulators in a TO220 package over there in my pile. So I'm going to point you at so you can kind of see me over there, what I'm doing. So I'll be back in a moment, and I'm going to go ahead and look for yeah, some replacement voltage regulators. Okay, I have found a 5-volt regulator, but it's in a surface mount package. It's on a tar amps, and that's not going to be ideal because I don't have a negative one that's the same, so I want them to build at the same rate, which isn't going to be ideal. Okay, what other donor boards have I got around here? Let's have a look. I think I've got a Hyphonics one somewhere. And there should be one on this SPO Dynamics board as well, actually. Where's my Hyphonics? If I can see the Hyphonics board. Okay, right, here we go. So there, I found a 5-volt regulator on this big ass Ground Zero 10K board. Obviously I'm going to be repairing this Ground Zero 10K board, so this isn't a donor board as such, but it can be a donor for now while I order some new voltage regulators. So we can, at least I can try some new different voltage regulators in this sundown and see whether it resolves the issue or not. So yeah, this is a bit annoying. So too many big boards on the bench. So the voltage regulators on this one are, by the looks of it, we've got that's a 15. So we've got the 05 is there, and the 7805 and the 7905 is there. Right, so it's the two ones that's closest to the center of the board. All right, so let's go ahead. I'm going to go ahead now and desolder these from this board. And then we're going to try these in the sundown board and see if the problem goes away or not. What do we think, guys? What do we think? I mean, I'm not massively confident because I'm a bit confused. I don't understand why adding the preamplifier board would cause the 5-volt regulated voltage to be delayed, but not the 15-volt regulated voltage. That doesn't seem to make a great deal of sense to me. Like, I'd understand it because if it was using the 5-volt rail, then yeah, I'd understand that. If it was using the 15-volt rail and it delayed the 15-volt rail as well, then I'd understand that. But it doesn't seem to be delaying the 15-volt rail. It only seems to be delaying the 5-volt rail, which it's not using. And what is supplying the 15-volt rail isn't, the 5-volt rail isn't getting delayed either. So it's a bit of a weird one. I'm not entirely convinced that this is going to solve the problem, but this is all I've got to go on at the moment. Okay, so there's our two voltage regulators desoldered from the donor board. Let's go and put this back. Okay, now we need to desolder the original small ones from the Sundown. I'm going to sort my scope out because I've done that thing where I calibrated it for different things. So let's put that back to 0, and let's just check we haven't got any rail voltage left in the capacitors on the board before we touch our soldering iron. No, looks good to me. No voltage spikes anywhere, so that's good. So let's turn our iron on and let's desolder these small voltage regulators here. Are there any boost caps along the 5-volt rail, says Prince? I don't think so. Let's have a quick look. So on the 5-volt rail, you've got that small regulator that's generating it. There are some caps around it, so there could be some caps that are causing some issues, but if the caps were causing the issues, I would have thought that they would cause the issue when the preamp board isn't present as well. Yeah, so there are a couple of caps to ground, which will just be holding some storage for the 5-volt rail. The thing is that we checked the supply that feeds the regulators seems okay, because we checked that. We checked the input voltage to the regulators, and the input voltage to the regulators wasn't fluctuating or wasn't delayed like it was on the output. So the only thing that I can think of is that it's the output from the regulators that's causing the problem. If this doesn't solve it, then I am actually going to put this down to potentially a design flaw in this amplifier's circuit design. And I would be very, very interested to have another Sundown SCV-6000D on the bench and compare what that one does and see if that one does the same thing. Because if the other one does the same thing, then I need to get in contact with Sundown and be like, yo, you got some stanky things going on here, bruh. H1 Nicholas, I do not think the voltage regulators are an issue. I believe if you would like to get rid of the bump issue, you need to increase the delay to turn on the signal to the MOSFET drivers. I agree with Nicholas. This is one of the things that I was considering doing before. Before I noticed this difference in how the plus and minus 5-volt rails are built, I was thinking to myself, right, the only way that I can think to resolve this is to leave the problem there but delay the turn-on signal to the MOSFETs. But I don't have the knowledge to know exactly what bits to add or change in order to do that at this point. But now that Nicholas is here, maybe we could do that. So if this doesn't solve it, then that's the next path that we'll take. We'll either take that path, or I will just say to the customer, don't turn the amplifier on after you have recently turned it off. Give it 5 minutes for the rail caps to discharge, and then turn it on. Yes, good to see you here, Nicholas, my friend. I don't know if you've seen all of the progress leading up to this point, and all the detailed kind of scope views of exactly what it's doing, all the things we've tried so far. But it's been a pretty interesting one for me, anyway. And like I said, I don't believe that this issue was caused by the amplifier's most recent failing. The amplifier's only failed one time, as far as I'm aware. I don't believe this issue has been caused by the amplifier's most recent failing. I believe that this has been caused, this issue is there from factory, whether it's a quality control issue at Sundown or whether it's a amplifier circuit design flaw, in that the delay isn't long enough on the turn on of the FETs. Do you mean like a soft clip turn on thing? Sort of, yes. So you have a soft turn on amplifiers, some amplifiers, to prevent them from being a pop through the speakers. However, this amplifier has a relay that engages many seconds after the amplifier is fully powered up to prevent a pop to the speakers. However, it still means that that pop can be there on the board, but it's just the speakers don't receive it because there's a relay cutting continuity to the amplifier section. But in order to prevent there being a pop in the first place, even within the circuit itself, then the thing that's causing the pop here is that the Class D switch wave is being activated before the chips which generate the PWM signal, that being the 027C and the LM211. The Class D switch is being engaged before those chips are receiving their correct VCC. So what happens is the chips are receiving their negative VCC a couple of fractions of a second before their positive VCC, and that creates a small bump or a small pop on the outputs or on the switch, on the wave, on the PWM path, which goes to the FETs. And because unfortunately the drive ICs are turned on at that point that the generation chips are activated, or they start to reach the VCC threshold, that pop is then sent through to the MOSFET gates, which causes the massive spike in voltage to negative rail. So like I said, I've not got massive confidence that doing this is going to resolve the problem, but using my normal methods of problem solving and finding out where the issue might be residing from, this is as much as I can do. I found out why it's happening, and I just need to find out whether it's because of a problematic component or a problematic design. So if this doesn't solve it, then the issue will be a problematic design, and then we need to either leave it as it is and tell the customer not to turn the amplifier on again after recently turning it off, or we can see whether, with the help of H1 Nicholas, we can delay the turn on time to the drive ICs, therefore preventing this thing from happening in the first place. I'm going to assume that the pin out is the same for these because I think they're a pretty across the board part regardless of their package size. To change the delay, do you change the resistor? Slow down the charge of the cap, H1 Nicholas. I'm not entirely sure. There will be some kind of timer, which is probably based around a capacitor, that kicks in the delay within turning on or activating the drive ICs. From memory, pin number 2 of the RS21844S is responsible for activating and deactivating the chip. So we are probably, if we're going to go down that route, if this doesn't work, then we need to be I think from memory, I think we need to be looking at pin number 2 and what's on pin number 2. I thought Sundown was a good brand. Yeah, the brand is okay, but Sundown did not design this amplifier. Okay, just get that into your head. This circuit was not designed by Sundown. Sundown don't design amplifier circuit boards. Sundown create that subwoofers is their main thing that they have that is unique to everyone else's, sort of. You know, they take a bunch of pieces and they custom tool a basket, and they have motor top plate and bottom plate geometry made, and they make unique subwoofers. Their amplifiers are generic circuit designs that have been around for 15 years or so, with minor tweaks here and there to improve reliability, increase power handling, etc. And because these circuits are tweaked and here, there, and everywhere, sometimes bugs can creep into the amplifier that has been caused by a tweak that wasn't picked up when this was tested, when the circuit design was tested. 1 second, I might just need to make a quick call here. So bear with me, I just need to make a... Okay, cool. That's that sorted out. So now, this is the moment of truth. Does changing these voltage regulators improve and resolve the issue with the PWM generation ICs turning on slightly skew with due to a difference in VCC voltage build from the regulators? Whew. So let's do the same test as we did before then. Let's take our 2 probes. Let's put it on the scope here. Let's probe pin number, this one and this one I think is the pins we need to probe. Turn the power supply on. And let's go. So we're charging the rail caps from stationary again. Okay, so now the rail caps have now probably most of their voltage in them, so this is good. Okay. Off, on. Ah, no! Once again, actually this looks even worse. That's even worse. So by fitting bigger voltage regulators, that is actually worse and more of a delay. So the voltage regulators are not the issue. Why does that 5 volts take forever to charge? Why is that so goddamn slow? Okay, so now that we've made the issue worse by fitting bigger voltage regulators, I'm interested to see what effect that has on the gate drive. Is that going to cause an even bigger pop than we had before? So let's turn our scope back onto higher voltage here, so we can see the negative rail here. So let's turn that on. So hang on a minute. Okay, I need to go ahead and zoom in and sorry. Okay, I'm going to go ahead and zoom in on this drive wave. So yes, there's like a fucking massive pop there. Boff! You see, that is a really, really long time that those FETs are given a full turn-on signal. Davis, did you place them correctly? There are different pinouts to the TO220 to the smaller package. I don't think so, no, because if there were different pinouts, then this just straight up wouldn't work. The amp's drawing very, very little current. It's drawing 1.5 amps. So hang on a minute. Okay, let's just check that these do have the same pinout, because Nicholas has made me question this now. So I'm going to go ahead and go on to Firefox, because that's what I use for my live streams, because it's the only thing that works with OBS. So let's go ahead and let's search for. This is the Kia 78L05 BP. Okay, so this is the pinout then. So number 1 is output, number 2 is common, and number 3 is input. So now let's check what it is for the regular TO220 package, and that is a Kia 7812. That's just a regular Kia 7812. So let's have a look at, I think it's AP, isn't it? I think is the one that we're looking at. So let's have a look at that data sheet. Yeah, that's the TO220. Oh shit. Oh damn. Okay. Nicholas, by the looks of it, is correct. That this is backwards then. What the fuck? Why would they change the pinout? Why would they flip it around between packages? That makes no sense. Do I definitely have the AP package? Alright. Oh damn, that's 7812. I need the 05. 05A. Ah shit. Okay, alright then. So why does the negative one work still? So what the fuck? So this the negative one then, let's confirm between the negative one. So the negative one's a Kia. Damn it, whenever I press the A button it changes my screen. So the negative one is a Kia 79L05 7905 BP. And then we've also got Kia 7905A, I think is this one. 7905. Oh, it's PI. PI. Okay, so for the 79L05BP, it's common input output. Common input, right, so the 7905 is the same pinout as the smaller package. That is bare complicated. What the fuck? Why would they do that? But the positive voltage version, we have output common input and input common output. So I need to flip the positive one the other way around. What the fuck? Why would they do that? It's a good job Nicholas is here, because I wouldn't have even thought to check that. Stupid fucking Kia bullshit. What is this? So listen to H1 Nicholas, guys. Great advice in the chat. Voltage regulators have strange pinouts all the time, it seems. So check them every time. Don't just assume they're going to be the same. And that is a lesson I have learned today. Okay, so this needs to go in backwards, my friend. That is, if we haven't killed the voltage regulator by putting it in backwards. I doubt it, because we're running very low voltage input. So the input and the output are very, very similar voltages on these at the moment. So there's not much potential difference between these. Still struggling with the sundown amp. Well, we're making progress. We found out why it's doing what it's doing. .7805 Ti is used as a switching regulator, so should be instant. Okay, cool. I've got PI here. Okay, so we flip that one round, solder that back in, and power it up again. See if that's made any difference. So what was the problem? Jim, I don't know if you can scrub back in the video, but I recommend watching probably from about 5 or 10 minutes in, and just I do a really big explanation as to what exactly is going on here. So hopefully you should be able to scrub back through the video and watch the first sort of 15 minutes or so. It goes on about exactly what's going on here. I don't think there's a quick, easy way for me to explain it, but I'll try. If you can't bother to scrub back, what's happening is that the driver board, the PWM generation circuit, is using a 072C and a LM211, and those need a positive and negative 5 volt VCC in order to function. Now, the VCCs need to be activated at the exact same time. If they're not, if one of the, in this case, the negative VCC reaches the VCC threshold before the positive 5 volt VCC. And what that causes a little pop or little bump, a little voltage spike down the PWM generation pathway. And the problem is because when the amplifier is turned on, very shortly after it's been turned off, the second the amplifier is turned back on, the drive ICs, they activate. And so the IRS 21844S drive ICs, they activate. And The problem is they are then active when this little voltage spike happens due to the plus and minus 5 volts not generating at the same rate. Thus, this sends a bump or spike from the LM211 and 072C. Therefore, that gets sent down the PWM path, and therefore that turns the FET on suddenly as a spike, which causes negative voltage rail to be boom onto the FETs and onto the speaker terminals. So what we have to do is we either have to delay the IRS21844S turning on so that the pop happens before it's active, or we have to sort out the plus and minus 5 volt regulated voltage so that they both build equally, and so that there's not a difference in how they activate. Alright, so that's turned around the correct way now, so the pinout should be correct. So let's go ahead and test that one more time. But I don't have very much hope now with this anymore. Okay. Let's just get her powered up. Again, helps if I turn the supply on. Oh, the negative, the ground has come out of the amplifier. I think. No, it hasn't. Okay, why isn't this working then? Or maybe the remote came out. There we go. Okay. Ah crap, looks like we're drawing some heavy current at the moment. So why are we drawing some heavy current? The amplifier is really sinking some current, 8 amps by the looks of it. And I wonder whether that is because the pinout of the of that voltage regulator is actually different to what it says it is online. And I wonder whether I actually had it round the correct way the first time round. So the way we can check that is because if this IC is getting stanky hot just now, then that would be why. Okay, now it's alright. The fuck? Why was it drawing current a minute ago then? Let's put this board back in. And it is this one that needs to go in, and not the other one. Huh, rare. Okay, that's strange. Okay, well I can tell that hasn't fixed it for sure because there's still a bump on the switch on. So let's see if I can do it from this side of the board. So let's see if I can show you that from this side of the board. So that was, I've got to try and remember which pin's which now from this side. I think it will be probably this one and this one. Okay, yeah, so it's building properly now, but we still do have a delay on the positive 5 volts. So we're either never going to be able to get rid of that delay, for some reason that delay's there, so I think we might have to go with Nicholas's plan then, and try and delay the IC activation time. Huh. So I have one more suggestion on this one. So if it's not the regulator that's causing the issue, but in between, so I'm going to let the rail voltage sink back down so that we're safe to touch the thing. So we've still got 8 volts on the regulator, on the rails. Now the one, so it's possible that so common things that go wrong on these amplifiers here. So I'm just looking at like common things that go wrong, and you see these very, very small green things that are marked L2. That one's marked L2, that one will be marked L something. L. This is a tiny, tiny inductor, and these tend to go bad. So while these still read okay on the multimeter, they need to read about 5 ohms. It's possible that one of these is slightly damaged in that it can't supply that much current. So if the inductor on the 5 volt path has been damaged so that it can't actually provide enough current, then what might be happening is that when the 5 volt regulator, which is here now, turns on, it demands some current through the inductor and it can't get what it needs, therefore there's a delay. So what I'm going to do is, once the rails have sunk down to a safe level, is I'm going to confirm which of these inductors is between the 15 volt regulator and the 5 volt regulator for its input, and then I'm going to temporarily bridge over and short out the inductor so that there is no inductor there, so that we have maximum amount of current passable between them. And then see whether that makes any difference to how this thing turns on. So, okay, so I'm going to flip the, no, fuck that. So we're going to look at the input pin of the positive, which is the 7805, and the input to the 7805 was pin number 1. So pin number 1 is the input over here. So if I check for continuity between the input here and the output of the 7815, here we go. So we have, here we go, there's a 5 ohm worth of continuity. So that means that it does go through an inductor, and the inductor that it goes through is this one, L3 on the board. Let's show you that. So the inductor that the voltage passes from the 15 volt regulator to the 5 volt regulator is L3. So what I'm going to do is I'm going to bridge over a piece of wire on L3 and on L4, which is going to be the negative one, so just to give them both exactly the same circumstances. And if therefore one of those inductors is struggling to pass current, then we should see the issue resolve itself. So those two babies are just here, L3 and L4. That's the ones on the end here. So I'm going to take a very small piece of lead. I'm going to put my head cam back on for this so you can see exactly what I'm doing. Okay, so I'm going to try and find a small piece of component leg, which is less easy to find now because I have a nice bin down here to put all my cut parts in and stuff, so there's not as many bits of old component leg floating around on the floor like there used to be. But it looks like I found one or two that would work here on the floor still. So let's go ahead and cut those a little bit shorter so that we don't short anything else out that we don't intend to. Sam, I hate to ask, but I just tuned in, and could you give me a brief catch-up on the problem? Can you scrub back on the video? I think you're the 4th or 5th person now to ask that, and I have gone through it every time, but my mouth is getting really dry. So if you're able to skip back on the video, if that would massively help me out, because it takes about 5 or 6 minutes for me to explain what we found so far. If you can't scrub back in the video, then let me know and I'll just explain it again. So just a really shitty job there, just temporarily bridging over these inductors so that maximum current can pass over through them. Okay, so let's now plug this jam back in. Power the board up once more. Sam, what solder brand and size are you using? This one. Actididi? What the fuck does that say? I don't know. I just get this stuff from eBay. 40, 60, 70 mil. Okay, so let's turn it on. Okay, cool, activated. So now that we've got the rails charged, that's the important thing, is to get the rails charged first, because the issue only presents itself when the rails are fully charged. We're going to go ahead and probe the same 2 pins now that we've bridged over those inductors, and let's see what happens. Nope, still a delay on the 5 volt rail, so it's not the inductor. And therefore, I believe there'll still be a big spike on the drive wave when we turn the amplifier on. And we can confirm that just by doing that, probing the low side drive. Let's see, is there still a big spike? Yep, still a great big spike on the low side drive when it comes on. So it's not the inductors. I don't know what the fuck else it would be, really. It's just it must be a design flaw. it must be a flawed design that causes the 5-volt VCC to the PWM generation ICs to be slow on power up, and therefore cause a spike down the PWM line to the FETs, causing spike to negative voltage route and potential MOSFET explosion. So the point we're at now, there's two choices I have that I can do next. Choice number one, inform the customer of the design flaw, potential design flaw, and advise him not to power the amplifier up if he has powered it down within a 5-minute period. Option number two is to spend another few hours with H1 Nicholas, possibly, working out if we can increase the delay time to the IRS21844S activation. What should we do? I'm tempted more to just say to the customer, don't power it up within a 5-minute period of powering it down. Tell customer, go from there. Focus Dark Audio says I should tell the customer. Well, I have actually already told the customer of this issue, but I thought I would take another stab at it and see whether I could resolve it. But I think if this is a circuit design flaw, then it's not as easily resolvable as doing what I'm doing with troubleshooting, tracing, fault finding. We're going to have to do what I was thinking from much earlier on, is to increase the delay time on the activation of the drive IC. H1 Nicholas, if you're there, buddy, how complicated is this going to be to increase the delay time? So it's IRS21844S. So I think the shutdown or the activation is on pin 2. Yes, Amir, if your car is in accessory mode and the amplifier turns on, and then you start the car, which then turns the remote on and off and on again pretty quickly, then this could cause a problem, and the thing can explode. But I don't know if this is a design flaw with all amplifiers. So when amplifiers are built in the factory, there will be tolerances between the components. So it's possible that some of these, I mean, if this is a design flaw, it's possible that some of these amplifiers, when they're made, the delay capacitor on the switch on for the chips is actually just over the threshold that the bump doesn't actually affect it. But there'll be some amplifiers like this one where the capacitor is a very, very slightly lower value, and therefore the bump does affect the output. Let's trace back on the SD pin of the driver and let's see what the circuit is like. Okay, cool, let's go ahead and do that. Alright, so I'm going to have to do this at a strange angle because the driver board is mounted. I don't want to have to unmount it again. So, okay. Let's just, before we go any further, just to show you guys, let's confirm the shutdown pin of that chip. I'm actually using the FAN chip in the board at the moment. And I wonder whether that could be causing an issue. I wonder whether the FAN chip activates quicker than the RS21844. I didn't actually think about that. So this issue has been present ever since I repaired it. Well, it might have been present before I repaired it. But Nicholas, what do you think about this? So the amplifier originally was using the IRS-21844S. I fitted the FAN variant of this IC, FAN-7393A. So could it be that I fitted the FAN-7393A, that chip has a slightly different turn-on threshold voltage that's more sensitive to the IRS-21844S, and therefore, although this is technically possibly a slight design oversight in that the voltages for the VCC should build at the same rate, the IRS-21844S actually turns on slightly later than the FAN does, and therefore using the FANs is what is causing this problem, even though it shouldn't really be a problem in the first place. But the IRS-21844S masks this problem. I didn't think about that. Unfortunately, I don't think I have any spare 21844Ss to try in this, just to see if that makes the issue go away. Oh, actually I do. I do have a board here that's loaded with 21844S, but I don't know if these ones work. Oh no, the board is fucked. Ah, it's got a bunch of burnt out resistors and all sorts. Nah, fuck that. Nicholas says no, shouldn't be an issue. Okay, right, let's discard that from our brain then. Okay, so let's go IRS-21844S. So I think pin 2 was the shutdown pin, so let's just show you guys that. If you were doing this kind of repair at home, this is the sort of thing you'd be doing. Looking at what the shutdown pin is. Here we go, I think this is the correct chip. 1, 2, yeah. So it's the 7 lead, 21844S, which is this one. So shutdown, yes, I was correct. Shutdown is pin number 2. So if we trace on pin number 2, I think I can remember where this goes from memory anyway. I think it goes to one of those weird transistors that's called like MAX, Max. It's got Max written on the front. Michael Habib Hughes, how's it going, my man? You can have a shout out for sure. So IRS-21844S, pin number 2. I need to get some more light on this actually. Let's bring one of my lamps over here so we can see this a little clearer on the head cam. I tell you what I'm going to do. I'm actually going to put the head cam down on the table, and hopefully the camera will actually, will it stay upright so you can view the chip as I'm probing it? Maybe it will. Maybe it will. Maybe it will. Okay, yeah, that kind of works. I can just leave the camera there. Damn it. Stay upright, you damn thing. Okay, there we go. Okay. It will focus in just a moment. If I bring my hand here, and it should focus on the majority of the stuff that's in the shot. It takes a little while. And these cameras really are a piece of crap. I mean, they were cheap, but they really are a piece of crap. There we go. Now it's focused, and now it's also slightly out of shot. Michael Habib Hughes, who decided to join me at a bad time, as in like having some camera issues. Right, so pin number 2 then of this chip. If we take a look at the chip, it is currently upside down. So we have a little notch here on the start of the chip, a little circle, and that tells us that's pin 1. So if we probe pin number 2, which is this one, and we're looking for continuity on pin number 2. So from memory, it goes to this inductor here, goes to L4 at the top, which is just going to be filtering out any rippling, which will tell the chip to turn on and off multiple times if there's rippling. So after the inductor, it then goes to this resistor, I think. No, it doesn't. Does it go to this resistor? I think I'm just touching the inductor again. Okay, it doesn't go to that resistor. It goes to this capacitor, C8, which is probably just doing some smoothing, so that's probably not going to be useful. It also goes to... doesn't go to that one, doesn't go to that one, doesn't go to that one. I think it's going to go to one of these small transistors over here. This is really hard to do with the board in... Actually, fuck it, you know what? Rather than using that board, why not take one of my spare boards and do it on one of those? That's a much better idea, Bevits. Right, rather than trying to do it on the fucking board itself, why not just take the spare board and do it from that? So I'm going to use my zoom in cam instead, because that's going to be easier. I'm going to hold the camera and all that jazz. So let's move the board backwards so fit more space on the desk. Like that. And now we can have a look at this board on the zoom in cam. Now I'm going to hold a camera. There we go. Okay. So pin number 2, where does it go? So pin number 2 is here. We already discovered that it goes to L4 over here. It doesn't go to this resistor. It does go to this capacitor, which is probably just doing smoothing. I think that goes to ground. Now, it should go to a transistor somewhere, which is going to be responsible for turning it on and off. Here we go. So it goes to this transistor over here, which is Q10. So it goes to pin number 2 of Q10. Now Q10 is one of those transistors which has MAX written on the front of it, and on pin number 1 of the MAX, I think, do we have anything coming from the board? No, pin number 1 of the MAX goes to this resistor, which is a 1003. And I think that's the only place that it goes. I don't think it goes anywhere else. Oh, it also goes to this 1004, which then goes to a bunch of capacitors and possibly ground. Oh crap, I was checking the wrong one. Apologies, my bad. So yeah, we were looking at this one. Ignore what I just said. So pin number 1 goes to this 1004. This 1004 goes between pin 1 and 3. So that's just kind of making a connection between 1 and 3 like that. Don't think pin 1 goes anywhere else. No, pin 1 doesn't go anywhere else. Pin number 3 goes to this capacitor C17. It also goes to this via on the board, which we need to flip over, which on the back of the board here goes, oh, well, it goes all over the place, to be fair. It goes to this pin on here on the board, which I think this pin on the board is probably going to be some kind of rail or some kind of activation. So the activation signal might actually be coming, I think the activation signal might come from the main board, from the muting transistor location, I think. So if we look at the muting transistor location on the board, here's the muting transistor circuit. So we have an NPN transistor, we have this bipolar, this ceramic capacitor, a diode, a couple of resistors. So I think from memory, that does come from that part of the board. Let's have a look. Let's confirm that. So we're looking at this trace here, which goes to pin number 2 and pin number 3. So it goes to pin number 2 on that side and pin number 3 on this side. So pin number 2 on this side is... Right, so pin number 2 is negative rail, right? So the pin 3 of the transistor, which is responsible for activation, pin number 3 goes first of all to negative rail, and also pin number 3 on this side, negative rail. So it's just connected to negative rail by the looks of things. Alright, so that's sorted that out. So pin number 3 is connected to negative rail. Pin number 1 is also connected to negative rail via this 1004 resistor. So I think that the delay of the activation of the IRS21844S is actually just a timed signal. It's timed by this 1004 resistor here. So I'm wondering, Nicholas, if we change R46 1004 to a higher value, will that delay the activation of the chips because it's taking longer for the rail voltage to pass from pin number 3 into pin number 1, which will then send that signal to pin number 2? Pin 1 on the transistor just seems to go to pin 3 via a 1004. I can't see it go anywhere else. So I think that the 1004 is actually what's giving the time delay between the turn on, because the turn on signal obviously needs to be negative rail, 0 volts, and whilst pin number 1 isn't negative rail, the output of this pin number 2 is going to be 0, but as soon as the voltage on pin number 1 reaches the correct level, then pin number 2 will then have negative rail on it, which will turn the chips on. So I'm thinking, if we increase the value of this resistor, will that delay the turn on time? Jed Williams, I think we've discovered that the fault isn't a fault, it's actually a design flaw with the circuit. So what we're doing now is we're looking to correct the design flaw. Nicholas says no, R46 is just a pull-down resistor. What the fuck? So if I can't see where else pin number 1 goes, it doesn't seem to go anywhere else. I'm just going to put my thing on here. Are you sure it's just a pull-down resistor? It doesn't appear to go anywhere else. Ah, no, wait. Shit, my bad. Okay, you're right. It does go somewhere else. I just didn't find it. Pin number 1 goes to 1003 over here. Camera's decided to come out of focus. Pin 1 goes to 1003 over here. 1003 goes to this capacitor. This capacitor then has negative rail on it. 1003 also goes to this resistor, which is again another 1003. Which goes to this 1D, and this 1D then goes to a bunch of other places. Over here, pin 2 goes to this other place. I don't know if that helps, Nicholas. Pin 1 on transistor should go to one of the output pins. No, it doesn't. Pin 1 on the transistor doesn't go to any output pins on the board. It goes to this 1003. Sorry, it goes to this 1003. Now let's see, does that go to any output pins? Nope. How about this side of the 1003? Nope. How about any of these pins on the 1D? Okay, so the pin number 3 of the 1D, which is kind of doing something to talk to this max resistor, this max transistor over here, goes to the 3rd pin from the end on that one, and the 2nd pin from the end on that one. 3rd and 2nd. So if we now put this on the board and we have a look, what's that going to on the board? 2nd one from the end there, what's that connected to on the board? That's connected to the muting transistor. Okay, so yeah, I think then the delay, changing the delay is going to be messing around with something in the muting transistor location. I've no idea where the hell you'd find a schematic for this board, so no chance of a schematic here. Alright, so it looks like then that the turn on delay is in fact set by, it goes into the board via this pin over here, pin number 2 there, and this pin over here, pin number 3 here. They're connected to each other. It then goes up the board to this 1D transistor, which then goes through some resistors to this max transistor, which then goes to pin number 2 of the ICs, which is the turn on delay, which is the shutdown pin. So possibly the issue, the thing we need to look at then is going to be on the main board, and we need to slow down the signal coming from the muting transistor location. So this is the muting transistor circuit here. So we have an NPN transistor, we have this 104 ceramic capacitor, and we have these two diodes and D51. The pin on the NPN transistor that is connected to the input of the driver board, which is used for the shutdown, is looking like pin number 1 of the NPN. So pin number 1 of the NPN is what is the output for the muting transistor. Perry has one of his this in one of his tutorials. 21 pin 1 on class 3, I believe. Yeah, actually I do remember something about the muting transistor circuit on Perry's guide. So we could have a look at Perry's guide and see if that gives us any hints on how to do this. Let's see if we can have a look on Perry's guide. I think it's generic class D number 2. So this is the same drive board we're looking at. I'm going to search here for shutdown. Here we go, shutdown function. So this is talking about the shutdown function. Pin 2 is shutdown pin. When it's very near 0 volts, the IC will produce no output. When it's near 5 volts, the IC will produce output. Okay, so it needs to have 5 volts on it. So that means, and it's referenced to negative rail. So this pin needs to have 5 volts above the negative rail on it in order to operate. In between those points, it behaves as follows. With a 1K pot connected as shown, wipe on, the IC drops out about 1.6 when transitioning from high to low. It begins to oscillate at about 2.1 volts when transitioning from low to high. If you try this, monitor the voltage that's being driven into pin 2 closely. If it's set too close to the positive 12 volt supply voltage with very little resistance between the wiper and the positive 12 volt supply, the amp goes into mute or shutdown. Muting transistor marked max most commonly will be damaged. So that's the max. This is a similar driver board, but not the exact same one, but this is the transistor that might become damaged if we do that, but that's fine. Expanded notes, here we go. Note the high side filter capacitors in this diagram are listed as 4 UF, on some boards we reach 5 UF. So pin number 2, this is connected to the high side FET. Oh no, this is a different driver board to the one we were looking at. Yeah, this is the smaller driver board with only 2 chips on it. Now I know Perry has done some stuff on the muting transistor area, so I'm just going to go and see if I can have a look. So someone mentioned that on the so Strictly Amp said Perry has one in his tutorial, 21 pin, one on class 3. Ah, yeah, this is the same. So he doesn't mention anything about the muting transistor location in this section, but I know that he does mention it somewhere. I think it's not generic class D area. I think it might be beyond the basics, maybe. Let's have a look in beyond the basics. Muting. Nope, not useful in there. Protection circuit troubleshooting, maybe? Delay circuit and muting circuit. Here we go. Those delay turn on of the audio muting is not really a part of protection circuit, but it drives many of the same components. So I'll show you how it works. Ah, damn, Firefox isn't letting me run Flash. Why doesn't Firefox run Flash? Privacy and security? Information? No. Okay, that's annoying. So I might actually just have to view this page in Edge. Edge actually works with Flash. Loven Tasratha Kuma, what are you doing here, my friend? What are you doing here? This is a pretty boring bit actually, because we're just looking at seeing if we can resolve a potential manufacturing oversight, a design flaw in this amp. And at the moment, this muting transistor circuit is something that doesn't usually get damaged beyond the NPN blowing. So to modify this circuit is a little bit over and above what I usually do. So just seeing if we can find some information on this. I wonder whether does OBS work with Microsoft Edge? No, it just displays a black screen. Okay, so I can't show you Microsoft Edge because it just displays a blank screen like this. So maybe if I turn on my head cam. Okay, so that was in muting transistor location bit was in where was it in? It was in protection circuit troubleshooting. Here we go. Yeah, guys, Microsoft Edge is crazy slow. Don't bother trying to use Microsoft Edge. Doesn't seem to be doing much right now. Oh crap, that's because it's trying to open fucking Vegas. Why is it opening Sony Vegas? I didn't tell you to do that. Alright, protection circuit troubleshooting. Here we go. Muting circuit. Right, let's now see the flash. We should see the flash thing work now. No, flash is still not working. Oh, for fuck's sake. I give up with that. Fuck Perry's guide for today. I opened it in Internet Explorer, guys. Hey, here we go. Right, so this is a generic turn-on delay circuit by the looks of things. I don't know if OBS will show you this not video capture, screen capture. Where are we? Display, no. Window capture 3. So it displays, but it doesn't display actually what I'm looking at. It just says allow block content. Why does it still say that? Allow block content. Still not working. Okay, well, fuck that. Fuck this. Alright, so I don't know how well the camera can make this out looking at my screen like this, but this is a generic turn-on delay circuit. So amp is muted when this point is high. So muting transistors. So this 117, fuck. So this is the amount of seconds after remote voltage application. So what is changing? Voltage, so this is the LF347. I don't know if we've got one of those on our board. But when the voltage of pins, what is this? No, on the capacitors, it's on some tiny capacitors down here. See, I don't even know if this circuit is the same as the circuit that we've got on this board. See, this is how good Perry's guide is. Perry's guide is full of these interactive demos here. Okay, I think I'm at the point now where we're just going to say to the customer, design floor with the amplifier, don't turn it on within 5 minutes of powering it down. And one other slight change I can make is that I can actually add some lower value pull down resistors to the main rails, because by adding some lower value pull down resistors to the main rails, what that allows me to do is that allows the rail capacitors to discharge quicker, so that the delay between turning the amplifier off and turning it back on again is much shorter, therefore hopefully preventing this issue from happening. So then I'm going to reassemble this, and we're just going to go with this being a design floor. Nicholas has asked for some snapshots of the circuit, so I'm going to take some pictures and send them to Nicholas anyway. And I might also edit these live streams to a really short little snippet, and I might send it to Perry Babin as well, because he might be able to suggest some modifications to make on these to improve the reliability and to prevent this from happening. Cool. So I don't need to live stream this anymore. That's pretty much done. I'm just going to reassemble this, put the original voltage regulators back in, take these big ones out, put the big ones back on the ground zero. And then we'll leave it at that, I think. I could try changing the Kia 7815s. Lavin, how long have you been watching for? What are you doing today anyways? How's it going with the Steg? The Steg, we're waiting for some drive ICs to arrive. The drive IC swap is the last straw on the Steg, and if that's not functional, then again that one's probably going to be going to Perry Babin. Since Michael Habib Hughes said hi. So towards the end of this stream then. Most of the action was earlier on in the stream actually. Towards the end of this was towards the beginning of the stream was nice interesting stuff, and towards the end was slightly more boring. Cool. Alright, well, I'll keep you guys up to date with my findings on this one anyway. But yeah, thank you for sticking with me through this. We found the problem. We know what is causing the issue. For those of you who have recently joined, the issue has been caused by a delayed a delay in the building of the positive 5 volt VCC for the PWM generation ICs, which causes the generation ICs, that being the 072C and the LM211 or 311, from emitting a small spike on the PWM line, which then gets sent down the line to the drive ICs, and if the drive ICs are active, then that also gets sent to the FET gates. That's the reason that this issue, it only happens when the amplifier is powered up after recently being powered down. After it's powered up from a stone cold empty situation where it's just been left overnight, for example, all the capacitors are empty, and so when the amplifier fires up, by the time that the drive ICs turn on, the PWM generation chips have already activated. They've already done their little spike, and it wasn't sent down the line because the drive ICs weren't active. However, if you turn the amp off and then quickly turn it back on again, the problem is that the turn on delay for the drive ICs is very, very short. There's not much of a delay at all. They come back to life almost instantly. And the problem with coming to life instantly is that the PWM generation ICs still need their VCC to be built again, and at that point the drive ICs are active whilst the PWM chips come into activation, and when that happens the spike goes from PWM to the drive ICs to the MOSFET gates, and when it gets to the MOSFET gates it turns the MOSFETs on fully for a long time, and that's why we see a great big spike to negative rail from the FETs, and there's a clicking sound from the amplifier, a bad smell from the bipolar capacitors, and occasionally the MOSFETs explode. Oh shit, did Zikan send me some money? I must have missed that on the stream. I've been so involved. Oh wow, thank you very much for the 20 sec buy, my friend. That's really, really kind of you. You need to break and buy some ice cream. You know what? Fuck it. I will go and have an ice cream because my throat is kind of dry from all this talking. So yeah, massive thanks to Zikan. I know you sent me 100 sec the other day, so man, massive appreciation for the very kind donations there, my man. Massively appreciated. So yeah, cheers for sticking with me, guys. What we're going to do, we're going to reassemble this, tell the customer about the problem, and advise him not to power the amplifier up too soon after he's just powered it down. And I shall catch you. I'm actually going to be streaming a little bit later on today again as well, probably. I've got quite a few bits to work through. My parts for the B2 Audio MA6K have arrived, so we're going to finish the repair on the B2 Audio, and then I'm going to move on probably to Giant's B201s. So that'll be pretty cool to see as well. And Giant, if you're on the stream somewhere, I don't know if you're watching this one just now, but I'll shoot you a PM just to let you know that we're going to be looking at your amps a little bit later as well. Thank you very much, guys. See you in